Hello and welcome to C Weekly. I'm your host, Jason Turner, available for code reviews and on-site training. In this episode, I want to talk about what is probably the least portable programming language ever created. Now, you're probably aware that C and C++ largely exist so that we can talk about low-level understanding of the languages while also having high-level constructs, relatively speaking, compared to assembly language. So I want to address that for a moment as well. I know that you're all probably thinking, well, assembly language is completely unportable. So how can you make a language that's less portable than assembly language? And I just want to make argument for the sake of this episode that assembly language is not a programming language. Assembly language is mnemonics that we have given to CPU instructions. Now I'm talking about an actual structured programming language that only works on one architecture. Before I carry on, I do want to, for this special 300th episode, give a shout out to my patrons who have been supporting me now, well, for 300 episodes nearly. I got my first patron very early on after I launched the channel, and this has been going for 300 weeks straight. It's not called C++ Weekly just for the fun of it. I have not missed a single week yet. So that is nearly 6 years of continuous episodes, sometimes more than one a week. So if you're interested in becoming a patron, be sure to check out the link. It's in the bottom. This is my patron page. A lot of people don't know, even my long-standing patrons, that if you are a patron, you do have access to an exclusive Discord. And that's one of the few places where I really make a point of responding to questions that people send me, because I get a lot of social media and email requests. But on Discord, for my patrons, then this gives me a focused place to know how and where to respond to people. So be sure to check that out. There's lots of different tiers, of course, as usual for Patreon. We're going to talk about C++. And if you're familiar at all with C++, then you're probably thinking about this programming language. It's a C-like programming language created by functional programming researchers Simon Peyton-Jones and Norman Ramsey. And it was designed mostly as a way for compilers of a very high-level language to create like an intermediate language. C++ in this regard is closer to the LLVM intermediate representation. And it was forked, actually, CMMM was forked as the intermediate representation in the Glasgow Haskell compiler, GHC. So if you're familiar with C++ and its history, you're probably thinking of that. That is not the C++ that I'm talking about. This one appears to be one that is actually portable. The one that I am talking about is Sphinx CMM. Now this date right here, this is the date that I loaded the page. This is just an old school website. This is not the date that this was last updated. And it says, look at last year's news. When was last year? No telling. But we have here, if we go to the About page, and you can see various broken links and such, that C++ was last updated officially by the author in October 28th, 1996. And they abandoned further development on it after that. Now, why this language is significant to me is because of this project that I worked on with my cousin JT back in, well, more than 25 years ago when we were both in high school. Now, if you are curious about this, or maybe you've already seen this episode, JT and I, back in June, did a couple of very long live streams to revive our old operating system project. And this screen that you are looking at right here, as I recall, was actually written in C++. So this comes from an interesting era. We're talking 1996 timeframe here. And the Sphinx C++ compiler says, the full documentation in English, it's a very big file, around 270 kilobytes, which is like insanely small today. Now this is, for whatever reason, characters that I don't have. Unfortunately, that page doesn't exist. You can browse the README. Now you can see that the person who took over development of Sphinx C++ went on to continue to make releases up until 2002. Now, this system actually has a full IDE and is actually a fairly complicated language. So let's see if we can pull up some of those docs. So like I said, this is actually a relatively high-level structured programming language, but completely unportable. We've got do, loop, while, for, switch, go to, break, continue statements. And you're probably still wondering, how can this be a high-level language that's completely unportable? And we'll get into some of the examples, which will make it, I think, relatively clear. It also can do optimizations for various CPUs. And you can see it supports up to Pentium 2. Here for Pentium 3, it says not yet implemented due to lack of information. Its default is 286 16-bit programs, or no, 8088 16-bit programs, or 386 when compiling in 32-bit mode. And so this is kind of the point here for how this can be a completely unportable programming language. As you can see, it expects you to directly operate on CPU registers. I can actually do AX equals some variable plus 4. This is absolutely expecting Intel CPU architecture. And we can see, like, you can define a procedure and you can, in the middle of it, directly set a CPU register. And we see this carry throughout all of the examples. But if you are interested, you actually can write relatively high-level code again. It's just at some point you have to be writing to a specific memory location or a register or doing something with hardware to actually get any kind of output from this. But you can create structs just like you could in C and say, okay, this is a byte, whatever, inside your structs. You can create functions, you can have structured programs, and then you end up going back to this kind of construct. And you can do indexed operations on these things with structs at specific memory locations and addresses and that kind of thing. So it's got this really crazy mix of high-level structured programming language and extraordinarily low-level fixed to one exact CPU architecture. And then you can see doing loops like this, loop over CX, and then have a for loop that is specifically using BX, and that's the 16-bit B general purpose register in the Intel architecture. You can explicitly put assembly instructions in here too if you don't want to use these higher level constructs. So I think that's enough of a kind of high level look at the language. I'm going to flip over to where I actually used this language for the sake of this episode. It's possible that you saw this episode of C++ Weekly from August, where I questioned how did dual screen games work in 1989. Now, there are very few of these things, although it turns out if you read the comments on this episode, which are actually really interesting, that there was a lot of development tools that supported dual screen development back in the 80s and early 90s. And they had VGA on one side and a Hercules monochrome adapter on the other side. So you could have actually two screens back in the 80s and 90s. And a lot of things, like I said, use this for debugging. So I wanted to kind of riff on that. And in this example on this episode, I write this absolutely terrible 16-bit assembly code that outputs just a couple of letters to the corner of the screen down here. And I promised in this episode that I'll eventually take this example one step further with a language that I'm sure that you've never heard of before. And here we are. This is C++. All right, I know the mouse records a little funny in this one, but I've got my C++ directory here. I downloaded all the Sphinx C++, and I've installed it here in DOSBox, and I've got my dual screen support, and you can see that I had this AB in the upper left corner of the bottom right screen in the recording. So it is actually, like I said, we've got a full IDE and a full compiler environment here. This is the set of examples that was actually available C++, and this is where I started from. So I'm actually specifying this is a 386. I want it to use 32-bit instructions. Code size model, resize model, I didn't touch those things. This example, the fire.c++, actually does a fire demo of like the flames being randomly generated creeping up from the bottom of the screen. And I wanted to take this example, which is all of this code right here that I'll admit I do not understand what it's doing. But you can see this doesn't have any structs in it. But you can see that it has do while type loops, and it has high level functions where it can write strings out in VGA mode. And if you're so interested, you can see where it is actually setting up VGA mode here at the top. And I've got my code that I inserted in, which is MDA clear, and that's to clear the monochrome display. And then what I have done is on each frame update, I'm going to update the frame count for this demo. And so I've written, again, probably pretty terrible code for converting an integer into an ASCII string. But I mean, it's not terrible. I can do up to 16 digits. No, up to 8 digits, that is, and I'm doing place plus equals 2 because if you recall from that last episode, I have to do character attribute, and I do a couple modulus operations and whatever. This digit plus 48 is to convert it from 0 through 9 to its ASCII value, and then I am writing out to this ES word, so ES is currently equal to AX. This is B1000. This is the address that is the start of the monochrome display adapter frame buffer, and I index into SI, and this is the location that I actually want to write on the screen, and I set it equal to the digit, which is equal to this value here. So that's again, the 0 through 9 plus 48 to convert this digit into ASCII. And we've got build, debug, all these things. And like I said, full IDE. So let's just go ahead and run it so you can see the result. Okay, so it shrunk a bit when it created the flame demo here because this went into VGA 320 by 200 mode. But we can actually see on the bottom right that I have my frame counting up and this demo running. And this is running in emulated DOSBox speeds, so this isn't too far off from how it would have actually been able to run in a 386 or something at the time. And this is like realistically the kind of thing that they would have done. I've got some sort of, important to me debug information in the bottom right screen here coming out the display adapter while my game or demo or whatever is running in the VGA adapter. So, there you have it. This is what I believe is the least portable programming language ever created, high-level programming language ever created, because it is so explicitly tied to this 32-bit Intel architecture. I hope you enjoyed this somewhat random diversion for my 300th episode of C++ Weekly, or shall I say C++ Weekly. It was fun for me to do the research and to put these things together, and hopefully you had fun, and I'm looking forward to the next 300 episodes.